Hello students, and welcome to part 2 of our lesson on intercepts. In this part of our lesson we are going to focus on examples of finding intercepts given an equation. So the first step that we talked about in finding the intercepts given an equation is to split the problem into two problems, because we know we're going to have to find both the x-intercept and the y-intercept. Now, let's start with the x-intercept. We know that for the x-intercept, it always looks like a number, comma, 0. So in other words, y is always equal to 0. So we're going to take our equation, which is y equals 2x plus 3, and we're going to substitute 0 in for y. So instead of writing y, I'm going to write 0. So I have 0 equals 2x plus 3. Now, we have a one variable equation because instead of having two variables, x and y, we now only have one variable, which is x. So if you want to, you can make your do and undo chart. If we knew what x was, we would have to multiply by 2 and add 3. So to undo this equation, we're going to have to do the opposite, so we'll have to subtract 3 and divide 2. So subtract 3 from each side. We get negative 3 is equal to 2x. Divide each side by 2. 2 divided by 2 is 1, and 1x is just x, equals, and negative 3 divided by 2 is negative 1 and a half, or negative 1.5. Now, we can't just leave it like this. This is just the x-coordinate. Remember, the x-intercept is a number, comma, 0. This is just the number that we're going to put there. So our x-intercept is the point negative 1.5, comma, 0. This is our x-intercept. INT is short for intercept. Now, step 2 is to figure out the y-intercept. We know that the y-intercept always looks like 0, comma, a number. In other words, x is always equal to 0. So we're going to take our equation, we're going to substitute 0 for x. So we have y equals 2 times 0 plus 3. 2 times 0 is 0, so we have y equals 0 plus 3, or y equals 3. So our y-intercept is the point 3, 0. Now, let's look at another example. Let's work to find the intercepts x and y of 2x minus 4y equals 8. And we know that this is written in standard form, so this is a linear function. So the first step is we're going to split this problem into two problems. We're going to find the x-intercept, and we're going to find the y-intercept. For the x-intercept, we know that y equals 0. In other words, when we write our ordered pair, it will be a number, comma, 0. The y-coordinate is equal to 0. So we're going to take our equation, 2x minus 4y equals 8, and we're going to substitute 0 in for y, which will change it from a two-variable equation to a one-variable equation. Now, it says 2x minus 4 times 0. Well, we know negative 4 times 0 is just 0, so we're left with 2x equals 8. This is a one-step equation, so we'll divide by 2 on each side, and we get x equals 4. So the x-intercept is the point 4, comma, 0. Now, for the y-intercept, we know that it will always look like a 0, comma, a number. That means that x is equal to 0. So we're going to take our equation and substitute 0 for x. So we get 2 times 0 minus 4y equals 8. 2 times 0 is 0, so we get negative 4y equals 8. One-step equation. Divide each side by negative 4 to create a coefficient of 1, and we get y equals negative 2. So the y-intercept is the point 0, negative 2. Now let's look at an example that involves fractions, because a lot of times our constant rate of change is not a whole number. So we have 2/3 y is equal to 4 minus 1/2 x. We're going to take the same steps and first split it into two problems. We have the x-intercept we need to find, and we have the y-intercept we need to find. For the x-intercept, we know it will always be a number, comma, 0, and in other words, y is always equal to 0. So we'll substitute 0 for y into our equation. So right now our equation says 2/3 y is equal to 4 minus 1/2 x. Substitute 0 for y, we get 2/3 times 0, which we know is 0, is equal to 4 minus 1/2 x. 2/3 times 0 is 0, so we have 0 equals 4 minus 1/2 x. Now, if the fraction is throwing you off, create a do and undo chart, because now you're down to a one-step equation. Look at what's happening to x. X is touching the negative 1/2, so it's being multiplied by negative 1/2. There is also an additional positive 4 being added to it. So the opposite of adding 4 is to subtract 4. The opposite of multiplying a fraction is to multiply the reciprocal, so the reciprocal of negative 1/2 is negative 2 over 1. So our first step is we're going to subtract 4 from each side. 0 minus 4 is negative 4. 4 minus 4 eliminates, leaving us with negative 1/2 x. And our second step is to multiply by the reciprocal, so we'll multiply by negative 2 over 1 and negative 2 over 1. Negative 1/2 times negative 2 over 1 will eliminate, because if you would multiply that, you get 1, and 1x is equal to x. Multiply the numerators and the denominators, add over 1 to your whole number. Negative 2 times negative 4 is 8 over 1 times 1, which is 1. 8 divided by 1 is 8, so x is equal to 8. That means that our x-intercept is the point 8, 0. For our y-intercept, we know that 0, a number is the layout of the ordered pair. That means that x is always equal to 0. So we'll take our equation, 2/3 y equals 4 times negative 1/2 x minus 1/2 x. And we'll substitute 0 for x. We have 2/3 y is equal to 4 minus 1/2 times 0. Now, negative 1/2 times 0 is just 0, so we're just left with 4 on that side of the equation. So we have 2/3 times y is equal to 4. This is a one-step equation because the only operation acting on the y is times 2/3. Well, what's the opposite of timesing by 2/3? Multiplying by the reciprocal, or 3/2. What we do to one side, we have to do to the other. Put over 1 under the whole number, so we get y equals, multiply straight across, 12 over 2, or y is equal to 6. So our y-intercept is the point 0, 6. Let's do one more example and then we'll look at a real-world situation. So we have an equation in standard form, and if you want to pause the video, you can try this one on your own and then replay it to check. We're going to split it into two problems in order to find the x-intercept and the y-intercept. For the x-intercept, we know that it will always look like a number, comma, 0. In other words, y is equal to 0. So we're going to take our equation and substitute 0 for y. So we have negative 3x plus 4 times 0 is equal to negative 12. 4 times 0 is 0, so we have negative 3x equals negative 12. One-step equation, divide each side by negative 3, and we get x equals 4. So our x-intercept is the point 4, 0. Do the same thing for y, except the layout of the ordered pair is always 0, comma, a number. So the x value is 0. So we're going to take our equation, but this time, instead of substituting for y, we're substituting for x. We're going to substitute 0 for x. So we have negative 3 times 0 plus 4y equals negative 12. Negative 3 times 0 is 0. So we have 4y equals negative 12. Divide each side by 4, and we get y equals negative 3. So our y-intercept is the point 0, negative 3. Now, let's look at a real-world situation. Our goals are to find the intercepts, graph the equation using those intercepts, and then talk about what each intercept represents. So a fishing lake was stocked with 300 bass. That means to start there were 300. And the population decreases, which is where we get the subtract sign, by 25 each year, which is minus 25 times x because it repetitively occurs. The population of bass in the lake after x years is represented by the function f of x, or the output of x. This is just another way of saying y. So if you're more comfortable, you can just cross out the f of x and write y, is equal to 300 minus 25x. So let's first start by taking our equation, y equals 300 minus 25x, and substituting values to find the x and y intercepts. So we'll first find the x-intercept. For the x-intercept, we know that y is equal to 0. So we're going to substitute 0 for y. Now, we're going to write 0 for y, so we have 0 equals 300 minus 25x. This has changed our equation from 2 variables to 1. So we'll take 300 away from each side. We get negative 300 is equal to negative 25x. Divide each side by negative 25 to get a coefficient of 1, or 1x is equal to negative 300 divided negative 25. Negative divided negative is a positive, and 300 divided by 25 is 12. That means that our x-intercept is the point 12, 0. Now we're going to do the same thing, but we're going to do it for the y-intercept. For the y-intercept, we know x is 0, so we're going to substitute 0 for x. So we have y equals 300 minus 25 times 0. Well, 25 times 0 is just 0, so we have y equals 300. So our y-intercept is the point 0, 300. Now that we have our two intercepts, we can create a graph. We don't have to be very specific with our graph because we know the certain numbers that we're going to. So our y-intercept is here at 300. Our x-intercept is here at 12. We know this is a constant rate of change because this is a linear function, so we'll just draw a straight line to connect them. Now, label each axis. The y-axis is the population. And the population depends on the number of years. So I want you to write a statement while I say it about the y-intercept and the x-intercept. The y-intercept is the point 0, 300. That means after 0 years, there were 300 fish. In other words, to start, 300 fish were in the lake. Now, look at our x-intercept. Our x-intercept is the point 12, 0. 12 stands for years because it's the x value, and 0 stands for the population, or the fish. So in other words, after 12 years, there will be no fish left in the lake. So write that sentence down. After 12 years, there will be no fish left.